Today you're going to solve systems of two equations in two variables, and you are going to do that graphically. When you solve those two systems graphically, you are going to have three possible types of answers. When you are solving this problem graphically, what you are looking for is the intersection point. You are looking for the place where the two lines cross. So we're going to solve this kind of problem using our graphing calculator. To get our graphing calculator ready to solve a problem, would you please first of all push this window button right here, and we are going to set this to a different window. This is the default window, but we are going to change this to the friendly window. We're going to type in negative 9.4 and push enter, positive 9.4 and push enter, 1 entered, and enter in these numbers. This is going to be the friendly window because when we use the trace button in a minute, it is going to make nice, pretty answers instead of ugly decimal answers. In order to solve this with our graphing calculator, we type both of our problems into both of our lines into our graphing calculator, and we push the graph button. And this is what we are going to see. We are looking for the intersection point. Push the trace button and you will see a little spider, and you can use your arrows to make that crawl across the line, and this is the intersection point. The solution is 2, 0 because that is the intersection point. Now, in addition to the intersection point, I want the graph on your paper to be accurate, not just sort of looking right. And so the first thing you're going to put on your graph is the intersection point. So that you can make these lines accurately on your graph paper, you are going to graph the y-intercept. This is the y-intercept of negative 6, and this one has a y-intercept of positive 4. And then you are going to take a ruler and make a nice, pretty straight line, and you're going to make a line that goes through the intersection point and the y-intercept and the other intersection point and the y-intercept, and that is a fairly accurate graph. On our next problem, you are going to type in both of these problems into your y equals part of your calculator. And when you push the graph button, this is what you see. These lines are called parallel lines, and there is no intersection point, so there is no solution. Now, how do I put that accurately on my graph paper? Well, over here on my graph paper, I'm going to have one y-intercept at negative 4, and the other y-intercept is at positive 6. One y-intercept is at negative 4, one y-intercept is at positive 6. The slope of both of these is negative 4. Let me remind you that slope is rise over run. So I need a fraction, negative 4 over 1. So I will count 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. That will be the first line. Now on the second line, I can't count down 4 because I'm going to go off of my graph. So I will count up 1, 2, 3, 4, and left 1. instead of counting -4 over 1, that's also equal to +4 over -1. And so then I will make my second line on my graph paper. Would you please use a ruler to draw the lines on your graph paper correctly? Now, I don't know why somebody misnumbered this, but this next problem is numbered problem number 4. It's not in y equals mx plus b form, so we need to get it in y equals mx plus b form. If we're going to have it in y equals mx plus b form, the y has to be by itself. I'm going to do the second one first. I'm going to solve this for y, and so this y needs to be by itself, so I'm going to subtract 3 from both sides. This is not correct because this has an x and that one doesn't, so we can't combine those terms. They're not like terms, so I would have -6 minus 3. And then I'm solving for y, so I'm going to divide everything by 3. This is going to get me -2x minus 1 equals y. We would usually write it the other way around. -2x minus 1y equals -2x minus 1. And then I have to take this other equation. Think you have room to keep going straight down your paper, and I need to solve this for y. So I need to add 2x to both sides. And then the 2x's cancel out, and this is 2x plus 1. But this isn't y, this is -y. So I need to divide everything by -1. And I notice here that I have the exact same equation. So what does that look like when I put it on the graph? It is going to have a y-intercept at -1, and it's going to have a slope of -2. Count -2 over 1, -2 over 1. You can use your graphing calculator. So that's the first line, and the second line would be right on top of it. And so what is the solution set? The solution set is all numbers on the line. How many numbers would that be? That would be an infinite solution because every number on the line is going to be in the solution set. So we have these kind of lines. Now this first one we can graph in our graphing calculator. If you put this in the graphing calculator, you will get a line straight across, a horizontal line. But this one cannot be graphed in the calculator because the calculator only graphs by y's because that's a function. So we're going to have to go over here 1, 2, 3, 4. There's my first line. This is going to be a vertical line that is going to cross the x-axis at -1. This is going to be a vertical line. This line is x equals -1. This line is y equals +4. Here is the intersection point. The intersection point will be at -1 and +4. Again, this system is not in y equals mx plus b form, so I'm going to have to get it that way. I am going to subtract 5x from both sides, And so I'm going to have negative 3y minus 5x minus 9. And I'm going to divide everything by negative 3. The negatives 3 cancels. Y equals negative divided by a negative would make a positive. 5/3 x. And this would divide and make a positive 3. And my second equation needs to be solved for x. And so if I solve that for x, I am going to, I'm sorry, I said the wrong word. I need to solve that for y. So it will be in y equals mx plus b form. I need to cancel that out because in y equals mx plus b form, I need the y first. And then I'm going to divide everything by 3 to cancel that out. And that would be negative 2/3 x minus 4. And then you're going to put this equation in y1 and this equation in y2.